Welcome back to our channel. Now we are on question 4. Okay, we have a reaction. Okay, to get all the things first. Okay, look here. State an expression for the equilibrium constant. Okay, corresponding to this equation. So look at it. Just state it. So very easy, right? Yeah, very straightforward. Just a concentration, right? But so straightforward. So remember to copy it completely. Okay. Concentration over the other two concentration, okay? Copper 2 plus and then Cl minus, and then remember they have different coefficient up there, so it should be powerful. Okay, so the macro value of Kc is like this. Okay, calculate the ratio. What ratio? Metachlorine ion is like, I think this is the ratio of these two things. Okay, I can't think of others, sorry, so you just write down. Okay, Kc, okay, I copy 4.2 times 10 to the power 5, and then it's these two concentration. Copy it. Okay, I'm lazy, I'm sorry. Okay, and then Cl minus to the power 4, and then you try to do the calculation to find out this ratio. Move all the thing to the other side. Okay, calculation time. What's the ratio between them, between this concentration? Pause and do it. Okay, really try. You need some experience of doing the calculator. Okay, because you can do it. Okay, I'm sure. Welcome back. Got it. 816.8. Okay. Okay, next one is a completely different question. It's about colored, and I explain why copper 2 plus is colored with reference to this electronic structure and section 17 of the data board. Actually, electronic structure is the most important thing. You remember copper 2 plus. There's a trick. Remember when the electron gone. Okay, for the copper 2 plus, for the copper ion. Okay, when the electron gone, remember the 4s electron will be in lower energy state. They will go first. Okay? And the remaining all the thing is on the right hand side. Yes, you need to remember the property of 4s and 3d when filling it or dissociate it or ionize it is different. Okay, really. So when you find out it should be a line electron here. Okay, line. Okay. So just join the 3d. Okay, 3d. Okay, wow. After joining it, you notice there is a unpaired electron. So you say I recognize okay, unpaired electron in a 3D shell. Of course, you draw this one out, okay? In the 3D shell. Good observation. Okay, and then this electron may transfer, okay, in a CU, okay, when the electron transfer, okay, when this electron transfer, and then you need to remember what is the color of a copper tubers, okay? It's blue, right? So from the data booklet, okay, from the color wheel, okay, it will absorb the opposite one, okay? Remember, not absorbing blue color. So when this electron transfer, okay, orange light is absorbed. Remember opposite. Light is absorbed. Yes, orange light is absorbed, so it has a blue color according to the wheel, okay? Has a blue color. Actually, you know the blue color first before you can find our orange light is absorbed. Backward engineering always, okay? Pretend you know nothing, actually know everything. Okay? By color wheel. Because you have to refer to the data book. Like data book just keep the color wheel and nothing else, okay? And that's it, okay? This is the solution for phi, okay? The important thing is you remember 4s will go first in ionization. Really? Not filling the shell, okay? Okay, see you guys. Bye.